collisions by Janessa Wright. The driving question for this project was, how do we protect the things and people we care about from collisions? To answer this, the rules of physics can be applied to the situation and a protective product can be made accordingly. Of course, research will have to be conducted to determine what provides maximum protection for objects and people in a certain situation. Here, the prototype is pictured. This prototype solves the problem of collisions that occur involving vessels and boats. Boating accidents claim thousands of lives and millions of dollars in property damage every year. Majority of the time, boat collisions occur between two or more recreational vessels. In the prototype, we see paper surrounding pom-poms. We also see construction paper surrounding the boat. These act as crumple zones. Crumple zones are a feature in vehicles that are designed to crumple easily and crash and absorb the force of an impact. They deform, redistributing the energy from the impact around the vehicle. On to the design process. The first step of the design process is identifying the problem. This was given in the form of the driving question. How do we protect the things and people we care about from collisions? Step 2 is identifying criteria and constraints. As always, one constraint is time. Students were tasked to submit certain parts of the project on a certain due date. Another constraint was that we weren't in the same school environment where the teacher was more accessible. So we couldn't receive guidance or ask questions as easily. The third step is brainstorming possible solutions. For this, I had to think, what materials are lightweight and effective at the same time? I also had to take into consideration how the material would affect the material I was colliding with. The fourth step was generating the idea. I decided to use crumple zone material, which was inspired by implementation of this material in cars. The question now was, where should it be placed on the boat? Step 5 regarded exploring possibilities. First, I thought I could form the crumple paper into a spike-like object around the boat, but that could easily further damage the object the boat was colliding with. Step 6 is select an approach. Ultimately, I decided to use spheres of compact crumple zones in between walls of layered crumple zones to ensure maximum protection while being generally lightweight at the same time. The seventh step was to build a prototype. My prototype was composed of pom-poms, thread, construction paper, hot glue, staples, and sandpaper as we saw before. I also made an origami boat to demonstrate the prototype on. Lastly, the eighth step was to refine the design. When creating the prototype, I decided to add more layers to the exterior of the design to minimize the need for the compact crumple zone sphere. Oil spills and fatalities. Oil spills can be prevented by the implementation of this product, as the prototype protects all vulnerable parts of the exterior of the boat. Oil spills, as you know, have detrimental effects on the environment, but they also cost billions of dollars annually. The estimated cost of a medium to large spill ranges from $2.4 billion to $9.4 billion. Additionally, boating accidents are especially common in Florida, and thousands of fatalities result from these horrific events. The links shown here are some resources I used throughout the project. Thank you for listening, and I hope you enjoyed this presentation.